Hey guys, what's up? Today in series of discrete mathematics, we are going to discuss predicates, quantifiers and its type, some important point and example related to quantifiers and its order. So let's get started with today's lecture. So what is predicate? It is a statement having the value either true or false, but truth value of predicate depend on some variable. Let's take an example. X is the capital of India. Here in this statement, the truth value of this statement is depend on the value of X. If the value of X is New Delhi, then it is true, otherwise it is false. Here the variable X is known as universe of disclosure. Quantifiers. So what are quantifiers? Quantifiers express the extent to which a predicate is true over a range of elements. Example of quantifiers are all, some, few, many, none, etc. So here we have types of quantifiers. There are two types of quantifiers. First is universal quantifier. It is denoted by this symbol, which is pronounced as for all. It is true for all objects of universe of disclosure. That is, if we have a given a statement like for all x, x is a number. Here, the value of x will always be a number, so it is true for all the numbers. The next quantifier is existential quantifier. It is denoted by this symbol, which is pronounced as there exists. It is true for some object of universe of disclosure. That is, if there exists x, x is a country. It is true for some values, not for all values. Here the value of x, if it is a country, then this statement is true, otherwise it is a false. Here we have some important points which are very useful in solving question. First is if all A's are B's. For writing this statement into quantifiers, we have to write for all x. Here we have AX implies BX. The next one is some A's are B's. For writing this into quantifiers, we have to write there exists some x such that AX and BX. Now we have no A's are B's. For writing this, we have to write for all x we have AX if AX then no BX. Here we have the last point, some A's are not B's. For writing this, we have to write there exists some x in AX which are not in BX. Here we have another 4 points which are very important in solving questions. First is all and only A's are B's. For writing this, we have to write for all x A of x by implication B of x. The next one is only A's are B's. For writing this, we have to write for all x B of x implies A of x. The next one is not all A's are B's. For writing this, we have to write there exists some A's, there exists some x for which Ax is not Bx. The last one is all A's are not B's. For writing this, we have to write for all A, for all x, Ax. If Ax, then not of Bx. Now let's take an example. Our first example are lions and tigers are dangerous animals. These are similar to our first point, which are all A's are B's. In this, our A is lions and tiger and B is dangerous animal. We know that from our first point, we have to write if all A's are B's in for all x, A of x implies B of x. Now we have to substitute the value of A and B for all x. Lion x, or we have to use OR operator here because lion and tigers are different. Tiger x implies dangerous x. Let's take another example. None of my friends are clever. It is similar to our third point, which is no A's are B's. Here, A are friend and B is clever. In our third point, we have write no A's are B's in for all x, A of x implies to negation of B of x. Therefore, we can write for all x we have friend x implies not of clever x. Here in this slide, we have to study order of quantifiers. If in a predicate we have given two or more quantifiers, then we have to consider its order as well. The order of the quantifier is important unless all the quantifiers are universal quantifiers or all are existential quantifiers. For example, all people are liked by all. This can be write as for all x, for all y, like x, y. And all people like all the people. This can be write as for all y, for all x, like x, y. These two statements are equal here, but when we have different existential quantifiers and universal quantifier mix, then it is not equal. For example, some people liked by every people. This can be write as there exists some x for all y, like x, y. Everyone like someone can be write as for all y, there exists some x, like x, y. These two statements are not equal. So friends, if you find this video helpful, please like, comment and share this video with your friends, and don't forget to give your feedback and subscribe to my channel. Thank you. See you next time.